This is a worked example on how to graph rational functions using the variety of theorems and methods from 3.1 to 3.2. So all I'm going to do, if you look in the previous page of this packet, I've got a list of things you can do to help graph a function. I'm just going to be doing that in this video. So the first thing you would always want to do is just factor, but this polynomial is already not polynomial, no. This rational function is already factored, so I don't need to do that step. I can move on to the next step, which is see what terms cancel, and you might notice that x plus 1 and x plus 1 cancel, and the resulting rational function looks like x minus 1, x plus 2. And so I want to write down this information of x equals negative 1 as a whole, but then I want to plug that value back into my original, or not my original, to my reduced function to find the y value of the whole. So negative 1 minus 1 and negative 1 plus 2. If I work that out, I get negative 2 over 1 equals negative 2. And so the xy coordinates of the whole is negative 1, negative 2. Okay, so let's keep going. I want to then set the numerator equal to 0 and solve. These are the zeros of my function. So if I set x minus 1 equals 0, I just get x equals 1 as my 0. So that's easy enough. Next, oops, forgot to delete this guy. Oh no, okay, hold on, there we go. All right, and so my next step is set the denominator equal to 0 and solve. These will be the vertical asymptotes. So I write VA for vertical asymptotes. If I set this guy equal to 0, get x equals negative 2. So that's, again, easy enough. My vertical asymptote is x equals negative 2. Then I can find any horizontal asymptotes or slant asymptotes. So if you remember, this is that list of 3 different cases. In this case, our degree of both the numerator and the denominator is the same. And so the equation is y equals the division of the coefficients. But my coefficients are both just 1. So y equals 1 over 1 is just y equals 1. Okay. Let's keep going. Next, we can construct a sign diagram. So I can draw out my sign diagram like so. And then on the sign diagram, you want to place both zeros and vertical asymptotes. And then you kind of want to label them to make sure you know which one is which. So I have a vertical asymptote at negative 2. You can kind of put a question mark so you know it's an asymptote. And then I have a 0 at x equals 1. So I can put a little 0 so I know that that's a 0. And then the same idea follows with all the sign diagrams we've done before. And I have packets and other videos for this, so I'll move a little bit faster than I usually do on sign diagrams. However, I look at the term negative 2 that was generated by the term x plus 2, and that's a positive linear line. Oh, come on. Okay, that's close enough, right? Positive linear. Then I look at the term 1 that came from x minus 1, which is another positive linear. Okay, there we go. And then I can choose my arbitrary points and find out what I have. So a point from here will pick up 2 negative values, and then those negative values being multiplied will be a positive interval. The middle point here will pick up a positive value and a negative value from my sign diagram, and so that's negative. And then my end point, or a point from here, will pick up 2 positive values, and so that's positive on my sign diagram. So I get positive, negative, positive. I'm not going to delete this sign diagram, but I'm going to make it a lot smaller just because it's taking up a lot of space, and I want room to make my graph. So I'll just put this down here. And I think the last thing I have written down is you can find the y-intercepts. So if I set x equals 0, then I get negative 1 over 2, and so my y-intercept is negative 1/2. Okay, now let's take all this information and try and actually graph this function. So I'm going to draw a nice big set of axes. And the first thing you want to do And these can be challenging, but always the first thing we should do is just fill in all the information we can. And I'll do it in yellow just so it stands out a little more. So, wait, let me add tick marks really quick. So, we shouldn't need too many for what we're doing here. Okay, so first, the whole is at -1, -2. And so the whole is going to be right here, and I can represent that by an open circle. Excuse me. My 0 occurs at x equals 1, so that'll be a closed circle right here. My vertical asymptote happens at -2, so I can draw, I want to draw as a solid yellow line, but just keep in mind that this is an asymptote. That's why I'm drawing it in yellow. Let me try and make that more centered. Okay, that's not really perfect. Oh, well, here, I'll do this. How about this? Start from here, straight line up, and then start from here, straight line down. There we go. Okay, so again, it's a solid line, but keep in mind that this will be an asymptote on my function, so this is not actually part of the graph. My horizontal asymptote is y equals 1, so I can draw that horizontally on the graph. And then my y-intercept is -1/2, so I can draw a point there. Now I want to fill in all this information, or I want to fill in the graph using all this information. This might look confusing, but keep in mind what we have here. We have the intervals where I can be positive and negative given by our sign diagram. So I know that everything from -2, that's this point right here, and to the left of that, all has to be positive. I then know that everything between -2 and +1, which is right here, that all has to be negative. And then everything from +1 beyond can be positive. I also know that my function is going to avoid touching my asymptotes no matter what. So I could really avoid drawing on those. Well, you should avoid drawing on them because they're asymptotes. However, I'm going to use them as sort of guardrails of where the function's going to exist. So in the top, starting from that interval, -∞ to -2, I can kind of draw my function on the positive region of the asymptote. Because keep in mind, well, let me draw it first, and then we'll talk. It's going to look like this. Now, we kind of get this shape by mimicking what the Laurent monomials look like, but what's more important to notice is that that function has to exist everywhere along that asymptote, right? So let's briefly think, and here I'll do it in blue, because this is our what-if scenario. What if I started below the horizontal asymptote? Because I'm still positive, I'm still above the x-axis, but what will happen here? Well, I need to start going in this direction. I can't cross the horizontal asymptote, and I can't cross the vertical asymptote. So as I keep going, I'm going to run into a situation where I have to cross that x-axis. But the issue with this is I can only cross the x-axis if I have a 0 in that location, and I don't have a 0 in this location. So there's no way for this blue line to ever cross that x-axis. And so really the only place that it can exist is not only positive, but above that horizontal axis, because I want to keep it from ever intersecting with a 0, right? Okay, so let's keep going. Now, this might get a bit easier because we kind of have a picture of where our points are lying. But again, I want to start kind of down by the asymptote here. And now remember, I want to trace through my points, but I also want to make sure I'm staying negative all the way until +1. So this won't be that bad. I can kind of move towards this hole, kind of skip over that, cross this, and my drawing is kind of not the neatest, as you can see. And then I can move up to touching that point right there. Now, ignoring how horribly drawn this is, notice that I have not changed from being positive at all. And the only place I'm allowed to start being positive is after +1. So after this point, I can now be positive, but keep in mind that I don't want to cross that horizontal asymptote, and so I have to kind of sort of bump against it and trail off towards infinity like this. And so, again, you can think of a really similar situation. If I tried to start my function up here, or sorry, let me use blue again. If I tried to start my function up here, well, first of all, that breaks the first rule of being positive before positive 1, so that doesn't work. And if I tried to have a function existing up here, we're going to run into some really weird issues because there's not an asymptote right here, and it just gets really messy really quickly. So even though these can be really tricky to get good at, trying to do a lot of examples and checking your work with a graphing utility like Desmos will really help you get used to what to do here. And Desmos will also draw much neater graphs than I've drawn right here, but really just doing a lot of practice problems and building intuition for what these functions look like is what it's going to take to get really good at this sort of problem. So here's a whole worked example. Feel free to watch the video as many times as you need and then give a shot at some of the practice problems throughout the packet.